Maybe.
X squared.
So we're going to start off with a whole bunch of equations that are various types that we have learned throughout the semester. Some of them will be things that we've done very recently, and some will be equations that we've done much earlier in the semester that you haven't seen for a while. And we're going to solve all of them using a quadratic method. Now, when I say quadratic method, there are a few that we have learned. The big ones are completing the square, quadratic formula, and then last week we learned the square root property. And all of these are really good methods for solving a quadratic, but the tricky part is sometimes deciding which method is the one to use. So, yes ma'am?
Can you repeat those again? I just want to study them later.
Square root property, completing the square, and the quadratic formula are the three big ones. They're all great in certain scenarios. The difficult part is, how do you know which scenario to use it in? So this problem obviously is difficult because it has a square root in it. It's got a radical in it. So when you're solving a radical equation at all, any kind of radical equation, the first step is always get the radical by itself. And so that's what we'll do first. We'll get the radical by itself. So we'll add the square root of x to both sides. That gives us, on the left side, x minus 6, and on the right side gives us the square root of x. So you've done these before. What's the point of getting the radical by itself? Exactly right. If you square a square root, what happens? It's just x. The squared and the square root cancel each other out. I also have to square the left side of the equation, though. So x minus 6 squared. X minus 6 squared is a distributive property problem. It's x minus 6 times x minus 6. So distributive property, x times x and x times negative 6. That's going to give me x squared minus 6x. And then negative 6 times x and negative 6 times negative 6. So minus 6x plus 36 equals x. And then we'll go ahead and combine the minus 6x's. Okay, so far, this is exactly like whenever we learned how to solve radical equations a few weeks ago. The difference is, now that we're done, I've got an x squared there. And that's kind of a key that this is a quadratic. And the way that you solve quadratics, no matter which method you're going to use, is that we want to get all the variables over on the left side. And if you want to solve these by factoring or the quadratic formula, you need to make it equal to 0. So that's going to be our next goal, is to make it equal to 0. We couldn't even complete the square here because it equals x instead of a number. So that's what it looks like after I subtract x on both sides. Now that I have done this, and the problem is a quadratic that equals 0, I've got two options. Option number 1 is to factor, and option number 2 is to use the quadratic formula. If you can factor this, factoring is for sure the quicker way to get the answer. If you can't factor it, we will have to use the quadratic formula. The quadratic formula will work no matter what, but I don't ever start with the quadratic formula because if it will factor, that is faster. So will this factor? Are there two numbers that I can multiply together to get 36, but when I add them, I get negative 13?
Yes, 9 and 4.
Be more specific.
Negative 9.
Uh-huh.
And negative, no. Yes, negative 4. Negative 9, negative 4.
Good. Okay, cool. So now what? Right, solve for x twice. Once with the left parentheses, and again with the right parentheses. This is pretty simple. The answer to the left side is
9.
9. And the answer to the right side is
4.
4.
So if you can factor, you don't have to use any of the formulas.
Right, and if you can factor, you should do it that way. Because the quadratic formula, although it works every time, takes forever. So we don't, quadratic formula is never going to be like our first go-to.
Okay.
No one ever says, wahoo, I get to do the quadratic formula. Not even your math teacher when the cable goes out says, yahoo, time for some quadratic formula. Okay, I think this blue marker has pretty much had it. Rest in peace, blue marker. We'll never forget you. We will call you Blue Man Group. You were so beautiful. You're my boy, Blue.
Beautiful.
So, what kind of function is this? Okay, true. Could you be more specific? What makes this scary?
Fraction.
Yeah, all the dang fractions. Let's get rid of them.
Yeah.
What could we multiply by that would get rid of all the dang fractions?
Oh, okay. That one is by x, and then that one is times x plus 1.
Exactly. X and x plus 1 is my common denominator. So the entire thing, every single piece, gets multiplied by x times x plus 1. Okay, so this first one, 5x over x plus 1, will be 5x over x plus 1, but now times x plus 1. Minus the next one will be x plus 4 over x, but it is now times x over x plus 1. And it equals 3 over x plus 1. Like so. Now, it sort of looks like we made it way worse, and when I say we, I mean you. This was your idea.
You agree?
But we actually, now that we've done this, can cancel all of the denominators. Because we picked something intelligent to multiply by, we can get rid of all the denominators. Por ejemplo, here, the x plus 1s are gone, which leaves us with 5x times x. Minus, here, the x's are gone, which leaves us with x plus 4, x plus 1, equals,
3.
yep. Okay, cool. Now this one is very, very tricky because of this right here. That's tricky to multiply together because of the minus sign in front of it. So we're going to be really careful. 5x times x is 5x squared. Then we're going to do minus, and then we are going to create a set of parentheses inside of which we are going to multiply these together. And we're doing it this way so that we can remember that whatever happens after I multiply these two things together, I'm subtracting the whole thing. So this is x times x, and x times 1, and then 4 times x, and then 4 times 1. Okay, and then we're going to combine these x's together to get 5x. All right? Now, this is the part you got to be careful about. This is 5x squared. Every single thing here has to get subtracted. So minus x squared, then minus 5x, then minus 4 equals 3.
Can we minus the x squared and that be 4x?
Not only can we should. 4x squared minus 5x minus 4 equals 3. And then we got to make it equal to 0 if we want to use any of these methods. Completing the square is not an option here. How come?
There's a variable in front of the x squared.
It's not a variable, it's a constant, but yes, because there's a number in front of the x squared. It's not impossible to complete the square when there's a coefficient. It's not impossible, it's just not fun. As opposed to the rest of this, which is a laugh a minute. Now, of course, my goal is always to factor if I can. This one's a little trickier. This is an ABC factoring problem. So A times C, 4 times negative 7, is negative 28. What are two numbers that will multiply together to give me negative 28, but when I add them I get negative 5? Numbers.
7 and 4.
Say it again.
Sorry. 7 and 4.
7 and 4 is not going to give me 5.
There is not one.
There's not one. What does that mean?
You cannot factor.
You cannot factor it. That's not great news.
Solution.
Nope, there's a solution.
Yeah, crappy one.
What is going on?
Quadratic formula, son.
Son.
Okay, so
No.
Well,
5.
So we just figured out in the last section that A is 4,
yeah.
B is,
Negative 5.
and C is,
Negative 7.
and so let's just plug them in. So negative B plus or minus the square root of B squared minus 4AC all over 2A.
It's just a pain in the butt.
This is kind of a pain in the butt, but if it makes you feel better, it's about to get way, way worse. So, x equals, so negative 5 is 5, plus or minus the square root of, so negative 5 squared is 25. What's minus 4 times 4
Negative
times negative
16.
7?
It's negative 16 and then negative 16 times negative 7.
Is
Negative 112.
so it's really positive 112 because it was minus negative over 2 times 4 is 8, which means the thing in the parentheses is 5 plus or minus the square root of 137 over 8. Now what? Huh?
I mean, it's square root of 137 is 137.
Yeah, 137 cannot be square rooted. That's a prime number, which means our two answers are 5 plus the square root of 137 over 8 and 5 minus the square root of 137 over 8.
How are you supposed to make sure this is right
What do you mean?
Now that you didn't completely fail on that.
Oh, it's really easy. What you do is you take these two answers and you plug them into the original equation. So instead of x plus 1, you'll replace this with 5 plus the square root of 137 over 8 plus 1. Do the same thing, 5 times
X.
5 plus. Yeah, replace all the x's with this thing
Oh, with the answer.
and make sure it works on both sides. And then replace all x's with this thing and make sure it works on both sides. I think that's pretty simple way to do it.
Okay.
I think that's a great way. It's a great way to check your
That's a
answer.
great way to go crazy.
10 out of 10, highly recommend checking
How
your
many
answers.
hours do we have on the final?
3.
3? Okay. That's doable.
I don't know about that.
25 questions.
Hmm?
Is it? 25 questions?
I've never said that.
Oh,
How many weeks do we have to study this?
Finals in 3 weeks.
we've had, what,
Wow.
16 weeks?
Counting today, 3 weeks.
Wow.
Plenty of time. What are you people panicking about?
Because right when I go to take a test, I freeze up, and then I'm just like,
Yeah.
Oh, well,
I'm in menopause.
okay, let me give you a piece of advice. Don't do that. Is that helpful at all?
Don't do what?
Freeze up when you take a test.
You know what?
Like if you're having problem, like you're freezing up during a test, my advice would be like stop doing that. And so I think that'll help you a lot if you just cut that out.
When I freeze up at home taking the quizzes, I have a
I
freaking
know.
anxiety attack.
Anxiety.
I think I'm doing okay, so I skip it. And I'm like, okay, I can do this. I don't know this one. I'm just gonna skip it. And then I get to the next one, and I don't know that one. And then it just goes down.
This is a really interesting story. You should keep going.
Yeah.
So, believe it or not, this problem can be factored. It can. True story.
Because you minus 3p. 4 and 1.
Yeah, now you're getting it. Instead of starting with p squared, it starts with p to the 4th. But all that means is when I write the parentheses, instead of each parenthesis starting with p, what are they going to start with?
P2.
Not p2. Good grief.
P2.
P squared. And now it functions exactly the same as it did before. What are two numbers you can multiply together to get -4? Well, when you add them, you get -3, and you just told me.
1 and 4.
Be more specific.
Negative.
Negative what? Negative 4 and positive 1.
There you go. This one here won't factor. P squared plus 1 can't factor, but this one can. What can p squared minus 4 factor into?
P.
2.
P?
P minus 2, P minus 2.
No, p minus 2 times p plus 2.
There we go.
P plus 2.
This one can't.
Yeah, I heard you first time, Taylor.
P squared plus 1 cannot be factored. Okay, now we're going to set each one of these parentheses equal to 0.
Each of them?
Each of them. That's what I said. Weren't you paying attention?
Yes.
Why don't you listen when I say things? You don't have to ask me all these questions. Jeez, no respect. Stop asking all these dumb questions. What do you think I am, a math teacher, for crying out loud? So these two are pretty easy. 2, -2. This one's not easy
Yikes.
because you can't factor it in case you hadn't heard. Square root property will work though. Square root both sides.
Oh.
What's the square root of -1?
One.
No, it's I.
It's I.
I thought that was completely wrong.
And when you take the square root, you have two possible answers, positive and negative.
Yes.
So the solutions to this problem, there are 4 of them. +2, -2, positive I, negative I. 4 solutions because we had b to the 4th.
So however many, basically however,
Go on. What's it?
exponents.
No.
There is
Power.
Power. The square thing.
Power.
How many power it has?
Yeah, however many powers there are.
Oh, lordy.
How many answers there's gonna
The degree. It's called the degree.
Okay.
That's how many answers they have. But you got to be careful because sometimes you can have something that's called a double root, which is where the same answer comes up twice.
Okay.
So it doesn't mean 4 unique answers. It means, so in other words, my answers could have been +2, -2, positive I, and -2.
Okay.
Like you could have an answer that repeats.
But would we write it down?
No,
Okay. So there's only 3.
there could, yeah.
Yeah.
Don't go thinking there's 4 unique answers. There's just 4 answers. Don't go thinking there's 4. I couldn't if I tried. You and me should do a duet.
Heck yeah. Right
I was-
now, let's light this candle.
I was just kidding.
We're on YouTube, why not?
Right?
I'm just gonna need my space. We should see other people. So this one looks really weird, but it can be factored.
Well, yeah, no, I can.
Now I'm gonna show you a little trick here that's gonna make this one easy to factor. Notice that both of these have x minus 3, where normally we would just have an x, right? Normally we'd have x squared minus 3x, and now this is x minus 3. So I'm gonna do a little substitution until we get to the end. I'm gonna replace all of the x minus 3's with y,
Why?
because now this is what it looks like.
So we're just allowed to do that because we want to?
Well, we're allowed to do it until we get to the end, and then we'll replace them back. But I think this is easier. It's easier to factor y than it is to factor x minus 3. We'll replace them when we get to the end. In calculus, this is called U substitution.
-3, -4, or +1.
Yeah, this one actually looks the same as the last one. The numbers that we want are -4 and +1. So we've got y minus 4 equals 0, and y plus 1 equals 0.
So we have y equals 4.
So y equals 4, and y equals -1. And now that we're at the very end, now we're going to re-substitute.
Now, really, it's x minus 3.
It's really x minus 3 equals 4, and x minus 3 equals -1. And now we'll solve these. Add 3 to both sides. And so our answers are 7 and 2. You could have solved that problem and gotten the correct answer if you hadn't done the y substitution. Like you can do it. Just not gonna like it.
I'm gonna have to write that on a piece of paper.
Right, what?
This little bit we would do.
Oh, I thought you meant you were gonna write, you can do this, but you're not gonna like it.
That too.
That's probably in all of your notes.
Yeah.
You're like pumping yourself up. You can do this. You're not gonna like it, but you can do it.
She said she has FML.
Yeah. Yeah. There's a lot of that going around. Sounds like you need a vacation. Oh, wait, you already took one this semester. That's right.
At the beginning of this.
Yeah, I remember that time you missed class for a week so you can go on vacation.
To Mexico.
I remember.
Before they closed the border.
To Mexico. Why would you need to go to Mexico? We have a Taco Bell in this town.
Oh God. I hate Taco Bell.
I went-
Is it because of the beaches? We've got sand here.
I like over there.
It's sand. It's all the same.
No, it's not. It's beautiful.
Yeah.
And the water is 5 different colors.
That doesn't sound good. Water came out of your faucet. It was 5 different colors. You'd call
You
some.
wouldn't say this is beautiful.
You'd call Fox News to come investigate. Is your drinking water safe? An Ariel woman's water is 5 colors. Okay. Now, it doesn't look like it, but this one can also be done using that substitution where we replace something with y. And we're going to replace this right here with a y. So y is going to be x to the 1/3. That's,
Hold on, X to the 2/3.
you'll see.
Because 1/3 and 1/3 is 2/3.
Yeah, because that makes this first one
This
y squared. X to the 2/3. 2/3 is,
Mhm.
this would be x to the 1/3 squared. X to the 2/3.
I'm so confused. I'm sorry. I don't want to do that.
Okay, let me come do it on my own side. X to the 2/3 is equal to x to the 1/3 squared.
How
So
is
we
it
replace
different?
this
With Y.
with y squared,
That's
since y
really
was x to the
just-
1/3.
okay.
Now the only reason we're doing this substitution is just because factoring this is easier than factoring this. That's the only reason we're doing it.
I thought it was
When we get to the end, we're going to substitute it back. We're just kind of cheating a little bit here. I mean, it's not cheating, because we're not going to get caught. What are our two numbers that will multiply for 6 but add for -5?
-6.
-6 and positive 1.
-6 and +1 gives me -6 when I multiply them.
So -6 and negative?
That would give me -7 when I added them.
How about -2 and positive 3?
-2 and +3 would give me -6 when I multiplied them.
Positive 3 and negative 2.
That would also give me -6.
Is it -3 and -6?
Sweet Jesus, what is happening?
She said, I'm just going to switch her around.
It's multiplication. Order doesn't matter, you maniac. 2 times -3 doesn't work, so what about 3 times -2? What is wrong with you?
-3 and -2.
So negative 2 and negative 3.
So y equals 2 and y equals 3, you crazy people. But remember, that's not really a y. It's really x to the 1/3.
Equals.
So x to the 1/3 power equals 2. And x to the 1/3 power equals 3.
But.
Because that's y. Like you just transfer the y into what we said it wasn't.
Yeah, I switched it back after I was done factoring.
Yeah, but wouldn't it be 1/3 like squared because it's
No.
X is 2/3?
I left the squared in. I factored that out. Yeah, no, I'm just replacing the y's with the x's.
Okay.
You multiply by 3.
Well, sort of. I'm going to cube both sides. Because x to the 1/3 cubed is x. What's 2 cubed?
8.
8. I'll do the same thing over here. Cube both sides. X to the 1/3 cubed is x, and 3 cubed is? 3 cubed is not 9.
27.
Your math teacher sucks.
No.
I don't want to make you feel bad, but that guy should be run out of town for the disaster he's created with you. Whew.
I agree. He's got me going mental.
Okay, so those are all questions that we have done before in this class. The difference is we didn't know quadratics when we did them. Now that we know quadratics, things get a little easier. We've got a few more tools for taking care of them. A few more ways to handle this. Any questions about those types of problems?
A lot, but,
This would be a great time to ask them. Do you have any specific questions, or are all of your questions like, my God, why?
just a negative 2 and positive 3.
We struggle with knowing when to use what method to solve it.
Yeah, good call. So the only one of these, like the very first one that had the square root in it, we got the square root by itself to use the square root property. Every other one we did, our goal was get it to equal 0. Because if it equals 0, you can factor, which is usually what we did,
And if you
or
can't
you can use the quadratic formula. Factoring should be your first choice if you can factor it, because that's way faster and easier. And if you can't factor it either because it can't be factored or because you just stare at it and you're like, I have no idea what the numbers are, like you think 3 times negative 2 is 6, for example, you can use the quadratic formula. I told you when we learned it last week that if you are throwing up your hands like, I just want one thing that works every time, that would be the quadratic formula. Although the quadratic formula gets really hard when you have these weird exponents like that. So it's good to have factoring in your
But
tool
you
belt.
can do it in the calculator if you wanted to, like the quadratic formula.
Yeah, you can do the quadratic formula in the calculator, but it gets real tough when it's not x squared, when it's like x to the 2/3. That gets pretty hard. But it can be done. You just won't like it.